For this hackathon, we want to present a front-end, a playground to play around with Kakarot. So a bit of background. What is Kakarot? Kakarot is a zkEVM written in Cairo for Starknet. How does Kakarot work? Kakarot is basically a smart contract deployed on Starknet that has all the capabilities of the EVM, being running opcodes, deploying contracts, keeping track of storage, and returning proper execution context. So in the end, it's basically an EVM inside the Cairo VM. Pretty inception. So let's move to what we wanted to present for the hackathon, which is basically a playground. What we did is that we forked the EVM.code's playground, which is very practical to run arbitrary opcode and seeing the results. And we basically want to compare the EVM implementation in JS, which is exact, to our Kakarot code. For that, I have arbitrary bytecode in the playground, and when I click run, the JS implementation of the EVM is going to run. And here we do actually a smart contract call, read a smart contract call in order to check our zkEVM implementation. And we can see that they are equal, so we're pretty happy. But we didn't want to stop there because we wanted to go beyond. So we had implemented the run functionality to just run arbitrary bytecode, and now we're going to demonstrate the deploy flow. So what do we need? I'm going to go in my notes and I'm going to grab the counter program. So in here we have the bytecode of the whole counter program, and then we get two functions, get counter, increment counter. So let's copy paste our bytecode, imagining that we are a young Solidity dev and we wrote Solidity, but we actually didn't want to just compile Solidity to Cairo. We wanted to have actual bytecode equivalents. So here we have our bytecode, we have our Argent account. So let's deploy. So we're deploying our account here. So basically what Kakarot is doing, we're asking Kakarot, our smart contract, to take this bytecode and deploy it in a specific account, and then map this account in order to keep track of it. So what we will do right now, basically ask our front end to increment the counter. All right, so let's try that. We put the call data, which is basically the function signature, and we know of our smart contract because I just pasted it in our code. And so let's try. Okay, we have one call that went through, and okay, we have another one. Let's do it 3 times, for instance. And now let's try and do get counter. So this call data specifically will call the get counter signature, and normally if we click here, we should see in the stack appear the number 3. Oh, okay, nice. So how do we know that counter is actually getting implemented and incremented properly? Let's just do it once more to be really sure. So executing the contract, the Argent signer is signing us by default. We have the return here. So let's do it again. Get counter, boom, execute contract. We should see 4 here. Nice. All right, so now we've proven that arbitrary bytecode, EVM bytecode, can be run in a playground, and the EVM and Kakarot will have the same output. So the same execution context, memory, stack. And then we also saw that we can deploy the hello world equivalent in Solidity, which is the counter program, and we can deploy it through Kakarot. So we can deploy it on Starknet as is. When I say as is, I mean the bytecode is as is, and we can execute it from Starknet call, and the storage will be kept. So we're pretty happy with these 2 features. In doing them, we had to implement 2 important opcodes of the EVM, which are storage load and storage store, store, load, and these allowed us to have kept storage. Thank you.